everyone, JJIR here, and in this video we're going to be doing quite a few things with a Raspberry Pi. In this case we'll be using a Raspberry Pi 4B that has 4 gigabytes of RAM, and we're going to be doing various configurations so we can have this set up from 0 to 100. And that will include SSH, overclocking, firmware, Wi-Fi, Bluetooth, VNC, and two-factor authentication. So to do this correctly, we're going to need 3 things. One is going to be the Raspberry Pi 4 Model B, and this one should have 4 gigabytes. Why 4 gigabytes? Because we're going to be using VNC, and that means we're going to be using a lot more RAM than if you were just going to be living in the terminal and doing nothing else. So to make sure that that runs smoothly, we're going to use 4 gigabytes here for this model. If you get something less, the suggestion here is that you do not use a GUI, but if in this case we're going to be putting a GUI on it, so the best case scenario is using 4 gigabytes. And if you want to go to the extreme, there's also an 8 gigabyte version, which is still not on Amazon yet, but hopefully in the future it will be available. Then the next thing we need is a micro SD card, and I have seen that this one here, the SanDisk Extreme Pro with 32 gigabytes, is probably the best option. The difference in speed is fairly noticeable, I found out, instead of using a cheap 8 gigabyte one with a normal speed. So the idea here is that if you can, try to splurge and get this one. If you can't, it's not a problem, but you're definitely going to see a speed difference in using this version of the SanDisk micro SD card and then using other ones. And then this is the charger I'm using. You can use a Raspberry Pi charger if you want, but in this case, because I have a Note 10 Plus, I was using the Samsung 25 watt one, and this one I have confirmed works perfectly fine. So you can use this as well if you do not want to get, or if you have this available, then just use this, or if you don't want to get the Raspberry Pi one. But this charger will work perfectly fine and give us plenty of wattage for what we're going to be doing with the Raspberry Pi, precisely because we're going to be overclocking this thing. And finally, because we're going to be overclocking, we're going to need some heat sinks and a fan. I got this case, which works out as well perfectly fine. It does make noise. I think almost all Raspberry Pi cases that have a fan will make noise. If you're in a silent area, probably the best option is not to overclock it. But if you are going to overclock it, just make sure you have heat sinks. And the fan is sort of an extra, but the heat sinks are just absolutely necessary if you're going to overclock. So this case is actually pretty compact. That's why I like it. I will be putting the links of all these things in the description, but it's just important to take in mind that these things I've seen have worked 100%. I'm not saying that you get them, but I am saying that they have worked well for me. So now that we have these 4 elements that we need, we can begin working with the Raspberry Pi. So just keep in mind that if you get all 4 of these things, you're talking about setting yourself back $100. So even though originally the Raspberry Pi was promoted as being something super cheap, if you really want to get this thing up and going in a very good manner, you will have to have about $100 to spend on these elements to make sure you have everything you need. So presupposing you have all these things, then you're going to go to the raspberrypi.org, downloads, and then Raspberry Pi OS. And what we're going to do is we're going to download the one that has with desktop here. And all you have to do is click on download zip to get this going. Now I've already downloaded this. This will take a few minutes because it's 2.5 gigabytes. So you're gonna have to wait about 15-20 minutes depending on your internet speed. So just make sure you keep that in mind before you start downloading it, because it will take a few minutes to download. So once you have that downloaded, then we're just gonna go over here to an app called Chrome Recovery Utility. Now this is basically for Chromebooks. But the funny thing is that this is actually an app that you can use to flash images to SD cards with. So in this case, we're going to take advantage of it, and we're going to open this up because we're on a Chromebook. So you can actually use this, or you can use another app, which is the Balena Etcher, which for Mac and Windows is perfectly fine. But given the fact that I wanted something that was even more universal that you could also use very easily with Chromebooks, that's why I chose to use it with Chromebook Recovery Utility, which works perfectly fine, and I've had no problems with it. So presupposing we have that here now, once we go here, and we've already previously downloaded the image file, the Raspberry Pi OS, then we're going to go here to the cog in the upper right, and we're going to click on Use Local Image. When we click on that, what we're going to do is we're going to look for the image that we had. And we know it's 2.5 gigabytes, so it has to be this one. If we move this over a little bit, you're going to see it says Raspberry OS Buster. So now that we know we have this, all we have to do is click on Open here, and it will automatically bring us to this part here, which is Insert your USB flash drive. We've already done that. we have our Extreme Pro here. So we're going to click on this guy, and then we're going to click on continue. And then after that, it's going to say that if you want to do this, you're going to delete everything on that. Okay. And we're going to click on create now. And now what it's going to do is going to start working with this. This is going to take some time. It usually takes a good solid 10 to 15 minutes. So you need to make sure you just hold tight there while it's doing that. And then what we'll do is we will come back when this is done so that we can continue on with the next step. Okay, so it has told us that it's now finished and ready to go. So we're just going to click on done here. And then we're going to go to our folder here. And we need to make sure we have a storage device selected, and then we're going to go to boot because we need to add 3 things here. So we're going to click on boot here, and then we have these wonderful selection of files, and we need to add some things here so this will work. First of all, we need to add an SSH file to indicate to the Raspberry Pi that we want to SSH into it. Then we need to add a Wi-Fi file to make sure that Wi-Fi is up and working. And then finally, we're going to put something at the end of a file to make sure that it can be overclocked. And those are the 3 things we have to do here before we can eject it and put it inside the Raspberry Pi. So for all of this, we're going to use an app called Caret. And Caret is a markdown text file editor. Very awesome. It can be used on any platform, basically. You can use on Mac, you can use on Windows, you can use on Chromebooks. And here what we're going to do is we're going to clear this up because we don't want this right now. And we're going to start from 0. So what we're going to do is we're going to click on File here, and then we're going to click on a New File. And in this new file, all we're going to do, we're not going to put anything inside. Actually, we'll get the one beforehand. We're not going to put anything in here. We're just going to go here and Save File As. And clicking on Save File As, we're going to put SSH. As you can see, we're not putting an extension either. All we're doing is leave it like that. And then we're going to click on Save, making sure that we are in the boot folder. So once that's in there, we're going to click on Save. And that one is done and ready to go. Then we're going to go up to File again, New File, and now we're going to add some text here for the Wi-Fi configuration. So for this, I have the elements PSK and SSID blurred out because it's information that actually exists here in my house. So the idea here is that you're going to put in SSID the name of your Wi-Fi network and in the PSK the password of your Wi-Fi network. And with those 2 things set to go, the rest of the text is going to stay exactly the same. So that needs to go in between the quotation marks here. Your password in between the quotation marks and the Wi-Fi name in between the quotation marks. That's the only thing you have to do here to change in regards to this text here. After that's done, then we're going to click on File again, and we're going to click on Save File As. And down here, we're going to change this name to WPA_supplicant.conf. And then after we're done with that, making sure again that we're in the boot folder, we're going to click on Save. And with that, that document's done. The third document we need to do is we actually need to go back to the boot folder here, and we need to find one that says config actually, and we're going to double click on this guy. Actually, we're not going to double click. We're going to right click on this, open with, and then afterwards we're going to go to open with Caret. It will open up something like this, and the only thing we need to do here is just go down to the very bottom to line 65, enter, and then we're going to add 3 lines here, which are the over voltage, which will be 6, ARM frequency, and the GPU frequency. So all of these are going to be put down here. Just keep in mind that the maximum for these guys here, this one is a max of 2,000, and this one is a max of 750. So I put them a little bit lower than those just to make sure that I don't have anything happening. In theory, you could go to the maximum, but the idea here is not to put this to the extreme. So these are basically the highest numbers that I would say that are safe for you to use just to make sure. And again, this is presupposing that you have heat sinks already on the essential chips on top of the Raspberry Pi, and you have the fan there just to make sure that everything is going to work out fine and you have no problems later on. So with that, we'll go up here to File, and then we'll click on Save File, Control S. And then with that, we have our 3 documents that we needed ready to go so we can pop the SD card in to the Raspberry Pi. So once we're done with this, we'll go back to the file manager here, and then we'll click on the eject button to pop that out. And then afterwards, once we make sure that that is done, then that will be finished, and we can finally now pass to whatever device we want to use, because the next thing you're going to do is you're going to put the micro SD card inside the Raspberry Pi. You're going to plug it in, and then from there, what we're going to do is find the IP address, the new IP address, the new local private IP address of the Raspberry Pi, so that we can SSH into it and begin to configure everything we want to configure inside the Raspberry Pi. Okay, so now that we have plugged in the Raspberry Pi, the idea here is that we're going to first SSH into it so we can do the entire process from SSH, or the terminal in this case. And like I mentioned before, you can do this on any device. In a previous video, I did it on a Chromebook. Now we're going to do it on an iPad, but you follow basically the same process. So the first thing we need to do is find the IP address of the Raspberry Pi, which is actually probably the hardest part of this whole thing. And for that, we're going to use an app on the iPad, which is called Wi-Fi Man. There's other ways of doing this, but Wi-Fi Man is probably one of the easiest. Now, this application is slightly unstable, so it may crash. Don't worry about that. It's actually pretty common with this one. But the idea here is that with this application, we'll find the IP address. So let's go here to Wi-Fi Man and click on this. It will first present our basic internet information, which is fine, but we're going to leave it like that, and we're going to go to the bottom of the app and click on Discover. After clicking on Discovery, we're going to let it search for IP addresses within the network. And we may have to do this a few times before it comes out. That's normal. So just swipe down and refresh to find other IP addresses on the internet and on the network. And you may have to do that 5, 6, 7, 8, 9, or 10 times even before it comes out. But just be persistent, and sooner or later the Raspberry Pi will come out. Okay, so for me it came out on about the 4th time that I swiped down. So now that we have it, it says Raspberry Pi.LAN right here. And it's giving us an IP address, and we're going to use that for the next step here. It says Raspberry Pi.LAN. So we'll take that, and with that we can actually SSH into that. We do not need this app for anything else, so as soon as we're done with it, we can now close it up and continue on with the next step. For the next step, we're going to use an application called Blink, which is a SSH terminal essentially that we can use to SSH into other things. So we're going to open this up now, and what we want to do is we want to put in the IP address that we previously found in the step before. So we'll type in SSH and then a space PI, which is the name of our Raspberry Pi here, the username, and then we have the @ sign and then the IP address. So we're going to click enter on that, and then we're going to type yes, and then type yes again. It's going to ask us for the password. The password for the Raspberry Pi when you begin is raspberry, and then we'll change that. It's not going to type anything here when you put the password in. Just make sure you type it correctly and then click on enter. And now it's telling us that we are inside, and the first thing we need to do is change the password. So we're going to type clear, then PASSWD, and then enter. And it's going to ask us for the current password, which is raspberry, and then we're going to type the new password in, which I suggest you make it nice and long to make sure that it's not easily guessed. Okay, so now that we have that, we're going to type clear again, and now we're ready for the next step. The next step in this case is going to be updating the firmware. Now I have already done this process because I've been using this for a little bit, but I will at least show you the steps so you can do this. So the first thing we need to do is actually update everything. We can't actually even do a firmware update until everything within the Raspberry Pi has been updated and installed. So what we're going to do here first is actually install everything we're going to need for all the processes we're going to see today. Okay, so first I'm just going to explain a little bit about what's going to be installed, and then we'll paste it inside the terminal here. So the first thing we're going to do is we're going to do an update, and the next thing we're going to do is a full upgrade. Then we're going to auto remove anything that's not needed there. And then we're going to install certain things that we need, which are going to be these things here. These are essential applications, I would say, that you're going to need for things in the future. And then down here we have this, which is for doing the firmware update. This will be for the VNC. This is going to be for the Wi-Fi. And down here we have Google Authenticator for our two-step authentication. And then here we have everything that we're going to need for Bluetooth. Then afterwards, we're going to install pip3 and Node for other things. And at the end, we're going to install some pip3 packages that we're also going to need for Bluetooth. So all of these things are what we're going to install right now. And then afterwards, at the very end, we'll do a reboot to make sure that everything is installed. So again, there might be some things here that you would think that are already installed on the Raspberry Pi or that are not needed, but I've seen that with all the things that one wants to do on a Raspberry Pi, 90% of the time these things are going to be used. So I would suggest installing all of this in one fell swoop just to make sure that everything's done so we can use those for the steps that we want to do in the future. So what we're going to do right now is in the terminal, we're going to paste that in and let it begin installing everything. As you can see, it clicked on working, and now it's going to do all this, and we will come back when it's all done and rebooted so we can continue on with the next step, which would be the firmware update. Okay, so now that it has already installed everything we need to install and rebooted, it's kicked me out, and so the only thing we're going to do here is type clear, and then we will SSH back into the Raspberry Pi. It will ask me for my password, and now we're in with everything updated. Let's type clear, and now we're ready to begin our next steps. The first one is going to be updating the firmware. Now I've already done this, but the idea here is that we need to make sure the firmware is up to date. So the way we do that, now that we've already installed the package we needed, will be the following. All we have to do is type this, the sudo rpi-eeprom-update, click on enter, and that will tell us whether the bootloader is up to date or not. If it's not up to date, in this case it is, but if it wasn't, then all we'd have to do is continue adding a -a to the end of this previous command, clicking on enter, and then the EEPROM would install the bootloader, the new updated bootloader. In this case, once that's done, then afterwards, all you have to do is do sudo reboot to make sure that everything is configured correctly. So presupposing that you've already done that, we can come back in and continue on with Wi-Fi. So presupposing that you've already updated your firmware, we're going to start on Wi-Fi now. And again, we've already installed a package from the first step that we did. So the only thing we have to do right now is configure it. And we'll do that with wicd. So the idea here is that you type sudo wicd-curses, and then we're going to click on enter. Okay, so I had to make the screen slightly smaller just so you could see the information. Unfortunately, I'll make it bigger in just a minute. But for now, just so you know, this has been the best application I have found to be able to control Wi-Fi from a terminal. It is an excellent application and has worked perfectly so far for me. So what this will do is it will give you a list of the Wi-Fi networks that are available. If you need to refresh this, as you can see at the very bottom of the screen, which is down here, you have all of these options that you can use, which is help, config, rfkill, connect, disconnect, refresh, prefs hidden, about, and quit. So all of these you just have to do is click shift and then the letter, and with that you're ready to go. So for example, in this case, if I wanted to refresh the list, all I have to do is click on shift and R, and that would refresh the list to make sure that anything that is new would come out within the list. And afterwards, once we have one selected, all we have to do is click on the right arrow key to go into the configuration of that Wi-Fi. Now, the one that's in green is indicating that we're connected to this. If we wanted to connect to a new one, we'd have to go down and select one of these. But we're actually going to stay on the one that's green because even though wicd has indicated that we're connected to this, we still don't have the configuration saved in wicd. So therefore, what we're going to do is we're going to click on the right arrow button to jump into this, to add the information to wicd to make sure that the information is there so that the next time we go in, we don't have to worry about it disconnecting. Now that we've clicked on the right arrow key, we'll go down and do two things. First, we're going to add an X here to automatically connect to this network, and we'll do that with the spacebar. The spacebar will add an X there. And then down below, we have the key, and we need to add the key to the network that we are already connected to make sure that wicd has this information. So after you're done typing in the password, all you do is use the arrow key to go up, and that way it's not selected. If you try to save this while you're inside the key box, it's not going to save. So once you're done typing the password, just click on the up arrow to go up one, and then afterwards you can click on Shift S to save this. But those are the two essential things you need to do here. If you wanted to, you can also put static IPs and all the other information that you need for your internet connection. But it's important to make sure you do this before you disconnect, because otherwise wicd will not have the information of this present wireless network which you need to make sure you connect in the future. So we're going to click on Shift S and then come back here. Now, my suggestion is you also connect your cell phone hotspot here. So the thing you would do is to activate your cell phone hotspot, refresh this, and then put in the information for your cell phone hotspot so that in the future it will automatically connect to that as well if you're not at home. Because when you go to some other place like hotel, you will need to connect to your cell phone hotspot first in order to be able to add the information of the Wi-Fi network in the hotel or wherever you're at. So it's important that you have at least one connection available that it will automatically connect to so that you can add other Wi-Fi networks. Once you're done, if the network that you're using is a new one, then all you have to do is click on Shift-C to connect to that new network. Given the fact we're already connected, that's not necessary, but you would do that for new connections. Now that we're done with this, all we have to do is click on Shift-Q to jump out of that, and now that's ready so that in the future it will automatically connect to the Wi-Fi networks that I have selected with an X to automatically connect to. The final step in the Wi-Fi is to make sure we deactivate the network manager that we were previously using. This is to make sure that wicd doesn't have any conflicts with it. So the way we do this is just by adding the following line. We'll add sudo systemctl disable dhcpcd. And then after we do this, when we click on enter here, it's going to say that it's going to do that. And now all we have to do is a sudo reboot once again to make sure that it is configured correctly. And then we'll come back in and start working on Bluetooth. Okay, so the Raspberry Pi is now rebooted. Rebooting only takes about 30 seconds to a minute. You should just give it a little bit of time so they can reboot. But afterwards, what we're going to do here is type clear, and then we'll SSH once again into the Raspberry Pi. Put in our password, and then type clear. Now let's begin configuring Bluetooth. So for Bluetooth, we have already installed the packages we need, so that's all ready to go. So the only thing we need to do is type in the following to make sure everything is up and running correctly. First, we're going to put sudo service bluetooth start just to make sure it's up and running, and then enter. Now we're going to put in sudo bluetooth ctl, and then enter. This will bring us to a Bluetooth shell, and now we're going to type in the following commands. Power on, and then enter. Pairable on, and then enter. Discoverable on, enter once again. Agent on, and then enter. Then default agent, and once again enter. Finally, we'll type quit to get out of this. Then type clear. Finally, to make sure that everything's working, all we're going to do is type in Bluetooth-CTL scan on to begin scanning for Bluetooth devices that are around us. To stop the scan, all you do is click on Control-C. And in this case, you would see what you have, what you found with scanning, and you would take note of the MAC address so you can use that for the next commands. So the next commands are going to be Bluetooth pair and Bluetooth trust. And here it says MAC, and the MAC would correspond to any of the MAC addresses that you found previously above. In this case, as soon as you found one, you just click on enter, and then afterwards you would type Bluetooth CTL trust, and then again the MAC address to make sure that that process is complete. And with that, the Bluetooth will now have full access to your Bluetooth device. Certain devices are going to need posterior steps, but in this case, for the basics, this is what you need to do to make sure that your Bluetooth is up and running. Okay, now that we have our Bluetooth up and running, let's continue on with VNC so that we can actually see a GUI of our Raspberry Pi from the iPad. So to configure VNC, we need to do three basic things. We need to edit two files and configure two things in raspbiconfig. We'll begin with the files because the raspbiconfig is going to have us reboot the system. So we'll configure the files first. So first we're going to go into the VNC server file to edit this. And again, you won't have to type any of this. I'll put that in the description below. But the idea here is that we first need to add a line to this file. So we're going to type this and then click on enter. Once you go into this file, usually it will be empty. In this case, we'll type I and then Command V, and we will type in the following line. If for some reason you have something within this file, just put this line at the very end. Afterwards, we're just going to type Command period to escape that and :X to save it. After that, we're going to create a password because the idea is we're going to use the old VNC process of entering and not the new one that real VNC wants us to use, because that forces us to use their application. So we're going to use another application, and therefore we need to create a password. So we're going to type sudo vnc passwd-service to do that, then enter. Then we're going to type in a password that should only be 8 characters long at most, and then once again, and then enter. So now that that password is set, we're done with that step, and now we have to edit another file. Type clear, then type the following: sudo vim boot config txt, which is something we have already edited actually, but we're going to go into it again and click on enter. So the first thing we need to do is uncomment these two lines here and put the resolution we desire. So we're going to go here, click on I for insert if you're not there yet, and then we're going to uncomment these lines and then change the resolution to what we want for the iPad Pro. Once that's done, then all we have to do is scroll down to another line to comment it out. So when we go down to the Pi 4, we have a line here that looks very similar actually to this line down here. This one has been commented out, this one has not been commented out yet. So we're going to comment this line out as well. And then afterwards, all we have to do is command period and then :X to save. And that is all we have to do with this file. And then type clear. Finally, to finish off, we need to go into the raspi config. And we'll do that with sudo raspi-config. And then click on enter. This will bring us to something like this. And we need to change two things here. So the first thing we need to change is under interfacing options. Go down with your arrow key and click on enter, and then go down to VNC and click on enter. Here we're going to, if it's on no, just use your arrow key to go on yes, and then click on enter, and then click on enter again. Finally, we're going to go down to advanced options, click on enter, and then go down to resolution and click on enter. Here what you want to do is choose a resolution even though one may have been chosen already. In this case, we're going to go all the way down to the last one and choose this one, because if in the future you want to add an external monitor without using the iPad, then you need to have a way of being able to see it. So in this case, we're just going to leave the last one selected and then click on tab to go down to OK, or if you're already up here, you can just click on enter, and then that will mention that it's already been resolved, and then we're going to click on OK and enter. Then we're going to tab twice to select finish and click on enter. In this case, in many instances, the raspi config is going to ask us to reboot. If it does, just click on reboot. If not, what we're going to do is do a sudo reboot here to be able to activate all these configurations, and then we'll come back to try to connect to our new VNC. Okay, so once we've let our Raspberry Pi restart, here we'll type clear, and then we'll mosh in again. And then we'll mosh in again. Type in our password and then enter, and then type clear. Now we're ready to try our VNC server. To do that, we're going to type VNC server and then click on enter. Once that's done, all we have to do is type clear, enter, and now we can actually go to our application to set it up there so we can finally see our screen from the Raspberry Pi. To do this, we're going to use an application called Jump. So let's jump into Jump. And once we're in Jump, we're going to go up to the right hand corner to click on the plus sign. Here we're going to type the IP address of the Raspberry Pi. Down below we're going to click on VNC, and then we're going to click on save. Afterwards we're going to go over to where the little man flying here is, and we'll click on this. It's going to ask us for our password. Remember, this is the password we created for the VNC, not your Raspberry Pi password. And then we're going to click on save password. And finally, OK. Once we enter, given the fact Raspberry keeps on thinking that we still haven't done the finishing steps yet, we're going to continue on to finish this off so that the Raspberry Pi registers that we've done the whole process. But as you can see, the resolution is perfectly fitted for the iPad Pro, and you're able to work on this in a perfectly good and smooth manner. So let's continue on with the steps. Next, we're going to add country, language, time zone, and then click on these two to continue. Once we're done, next. Here, the Raspberry Pi still doesn't quite understand that we've already changed the password, but we can put in the exact same password we had before when we started off this whole process, and there's no problems. So once we put in the same password we had from the very beginning, all we have to do is click on next. Then it's going to ask us if the screen shows a black border. This is specifically designed so that if you connect an external monitor, you can fix this. For now, we don't have to worry about it, so we're just going to click on next. It's going to ask us to search for networks, but we've already disconnected the previous network manager, so we're just going to skip this step. Finally, it's going to ask us to check on update software, and we'll click on next. Now it's installed anything that was missing, and now we just click on OK. And then now that everything is ready to go, we can click on restart or later. In this case, we'll just do later. And now our VNC is fully functional and ready to be used. As you can see up here, we have the possibility of clicking on Raspberry, and all of our applications will now be able to be used. And one of the advantages here is we have Chromium here already set to go, so we can use that and configure it as we so wish. Once we're done with this, all we do is go to the three dots here in the part above, click on that, and then here click on the X to disconnect. And now we finished the VNC server, so now we're going to see how to set up two-step authentication. Okay, so for two-factor authentication, we're going to use Google Authenticator, which we have already installed from the very first step we did at the beginning of the video. So in this case, the only thing we have to do is to configure it so we can finish off our process of configuring the Raspberry Pi. In this case, the only thing we have to do is type the following. First, we're going to change a configuration, and we'll do that with a sudo vim and then going into the sshd_config file and clicking on enter. Here we're going to find the line that says challenge response authentication and turn this to yes. So here we'll change no to yes, command period, and then :X to save. Type clear to continue. After we change the challenge authentication response to yes, we have to restart the SSH. So we're going to do command V here and do sudo systemctl restart SSH and then enter. Now we'll type Google Authenticator without the sudo to configure this app. It will ask us a few questions. For the first one, we're going to type Y and then enter. It's going to throw out some information. It tries to throw out a QR code, but that doesn't work. So what you're going to need to use is the your new secret key is. After this colon, a code will be there. You're going to select that, copy that, and paste it into your authentication app, whether that be Google Authenticator or it be Authy or any other authenticator app you want to use. But you have to put that code inside the application to register this so you can use it in the future. As well, you should also take note of your emergency scratch codes to make sure that if for some reason your Authy app does not work, then you can have these codes just in case. So after you have the code, or rather the key in this case, the secret key, already registered in your Authy app and you have the scratch codes jotted down, then we're going to continue on with the next question. Next question, we're going to put type Y for yes, for time-based, and enter. It asks if we want the authenticator file to be edited, and we'll again put Y for yes and then enter. It's going to ask us again for another question. In this case, we're going to put Y for yes for avoiding man-in-the-middle attacks and using login about every 30 seconds. Asks us if we want to extend the time up to 4 minutes between client and server, and we'll put no and then enter. It also asks us if we want to enable rate limiting, and we're going to put yes and then enter. After that, we'll just type clear. Finally, to finish, we need to edit one more file. We'll do command V and we'll put in this here, which is to edit the etc. pamd file, and we'll click on enter. Below include common auth, we are going to add the following, and after that we will put command period and then :X to save that and then enter. Type clear, and then again we're going to type sudo systemctl restart SSH and then enter. And now we will do a sudo reboot. Okay, so now that we've rebooted, now all we have to do is to mosh in again and then enter. It will ask for the password and then the verification code that we're going to copy and paste from the Auth app. In this case, I've typed it in and then I'm going to click on enter. And then it will let us in. Now, the reason why it says that there is a detached MOS session is because Blink actually crashed when I tried to put this in the first time. So don't worry about that, just start it up again and put it in and you should be fine. Now there is something I want to mention here. I'm going to exit out of this and then clear. Now before I actually had Mosh Raspberry, which was a host that was saved on Blink, but the funny thing is that it's giving an error when you do this. I've already mentioned this to Blink, hopefully they're going to fix it soon, but for now the only way of going in this with two-factor verification is you're going to have to put it in manually. So instead of having a host already saved here, you're going to have to go back up and do it the way we said before, which was using Mosh and then the IP address. So when they get that fixed, I will put a comment in the description mentioning that it's been fixed so you guys can use that again. But until then, if you want to use two-factor authentication, you will have to manually put in the Pi and then the IP address of your Raspberry Pi. Now, the other thing we can do is actually set up a SSH certificate, and that will also help us to avoid this problem. So it's actually more secure than using two-step authentication. So what we're going to do now is we're just going to finish this off, seeing how to do that with the certification so that we can actually jump completely over the two-step verification type of thing and use a certificate, which is much more secure and much easier to use. So if we wanted to use the SSH certificate instead of using two-factor authentication, then we can do the following. And what this will do, it will copy the certificate over to the Raspberry Pi so we can jump in without having to use a password. So the first time you do this, you will have to put the password in, and then afterwards, no. So for now, we'll just type this and click on enter. Now we'll type yes and enter. Type your password, enter. Verification code, enter. Type clear, enter. And now try to SSH in again. Typing this, we'll click on enter, and it let us in because now we have the certificate already there. So we have these two options to use, either the two-step authentication, or we can use the certificate. And again, the certificate is much more secure. If you only want to use the certificate and not even use the two-step authentication, then we can do the following. We can type what we typed in before, the sshd_config, enter. And then we'll change the following. Use spam to no, challenge response authentication to no, and password authentication to no. Command period to escape, and then :X to save. Enter. Now we'll type systemctl restart SSH to configure that again. Enter. Now we can exit out, type exit and enter, type clear, and now we're going to go directly inside with just using the SSH instead of using the password and two-step authentication. As you can see, we've already jumped in. And with that, we finished off all of the configurations that we need to do. If you have any questions about any of these processes, you can leave them in the comments below. Please give a thumbs up if this helped you, subscribe if you liked it, and I'll see you guys in the next one. Take care.